Hey guys, just wanted to do a quick video going over Circumcenter, Incenter, and Centroid. Circumcenter is basically the point of concurrency where if I were to draw a circle, it would go all the way around. So the purpose of the Circumcenter is to draw a circle around the triangle. All right, so it's made by perpendicular bisectors, and I did the constructions there, going from the vertices, drawing my arc there and on both sides, and then finding a point equidistant from these two, drawing my perpendicular bisector. And I did that for all three sides. And when you do the perpendicular bisector on all three sides, you find that point of concurrency, the circumcenter. All right, and from that point, it is equidistant to the vertices. So this point right here is the same distance to all three of the vertices, and which leads to why then you can draw the circle around it like that. All right, so that's where you get your circumcenter. Okay, perpendicular bisectors get to that point of concurrency, which is equidistant to the three vertices. Because it's equidistant to the three vertices, then you can do your circle all the way around it. All right, that takes us now to incenter. So incenter is you're making a circle in the center of the triangle, right? Incenter, clever name, right? Your purpose is to get the circle in the center of the triangle. This is made by angle bisectors, right? So I did the angle bisector, I put my point on the vertex, and I make an arc, and then from that arc, I set my compass to make two arcs to demonstrate or create a point that's equidistant to these two guys, and then I draw my line. And I do that for each angle, right? Now, this clearly shows that my construction was a little off. I maybe wasn't in the total vertex when I was making my my arcs, or something went a little awry. But if you make a point then right here in the middle, that represents your incenter. And then from your incenter, you can then make a circle inside, so it touches all three sides. Don't mind me here. I'm just going to get in here and make that circle now. Woo. Right? So you make a circle inside the triangle, right? So this point here, the incenter, is equidistant to the three sides, right? The point is equidistant to the sides, angle bisectors, it's a circle in the triangle. Okay, last one is your centroid. Centroid's your center of gravity for the triangle, all right? And that's made by medians. And to do that then, so what I had to do is from the vertices, I do the perpendicular bisector construction, and then I mark where the perpendicular bisector would be. So I made those marks there. And then a median is from the vertex to the middle of the opposite side. So I did the perpendicular bisector construction for each side, so that I can find where is that cut in half, where the side's cut in half. Okay, then you draw your medians, and boom, look at that. You have your point of concurrency. This one's the centroid. So if we were to cut out this triangle and use my pencil tip and just kind of lay the triangle on that pencil tip at that point, that would be the center of gravity. It would stay perfectly flat, awesome, right? Another thing with the centroid is the distance from the centroid to the vertex is twice the distance of that from the centroid to the side. So for example, if this was 2, then this would be 4, okay? And that's something you would need to know. And now it doesn't mean that all the medians are the same. They wouldn't be. So if this one was 3, then this would be, you guessed it, 6. I'm proud of you. Nice job. All right, so so that's the centroid, center of gravity of a triangle, made by the medians. And the centroid divides the median into 2 parts. The centroid from the vertex of the centroid is twice the length of the vertex or the centroid to the side. Okay? That covers it in 5 minutes, just over. I hope that helps. Watch as often as you need to. Yippee skippy. Bye, guys.